common data. Also, maybe some variation in data. And variation in algorithm.
C++ の95年の C++ の視点をコモナリティとバラエリエーションのそういう分析のツールとして考えると OO っていうのはこの今言った4つのこと、コモンシグネチャー、コモンデータでバリエーションとあとバリエーションにアルゴリズムを持っているものです。
So, if I have an inheritance hierarchy of shapes, I can ask their area. So, commonality in signature. Area, rotate, move, all of these methods. But the algorithms are very different. The algorithm for rotating a square is, you can figure it out.
シェイプを、このOO について考えてみるとですね、コモナリティだと例えばどんだけ面積があるかとか、いくつかコモ共通するとか、ローテートするとか、その辺のことは共通として持ってるんだけども、実際、アルゴリズムだとかその辺のことはいろいろ変わってバリエーションの方に入るということを説明していました。
So, we have an algorithm for rotating a square. That's a different algorithm than for rotating a circle.
スクエアの、アルゴリズムと、スクエア、サークル。
Rotating a circle is the most efficient algorithm I have ever written.
You do nothing.
But it's the same signature.
シグネチャーは一緒だ、その時は。
So you see how I kind of took this world and and put them together.
これ見てみると、88年の OO の C++ のものと、学んだ94年の時に学んだドメインアナリシスのものとミックスしたものが真ん中にある。
But wait a minute.
ちょっと待って。
C++ has ways, it's a kit. It can express common signature, common data, variation in data, variation in signature, variation, in name. Wow! So, wow, what's commonality in signature and commonality in algorithm with instantiation? Well, that's another paradigm. That's modules.
ここで言われているコモナリティとかそういうのがに、今までと違ったパラダイムとして考えられる。それはモジュールでとして、考えることができるんじゃないかと。新しいパラダイムです。
You mean the C++ offer a different set of commonality and variability than just object orientation?
Yes. I mean, object orientation is one way of combining the commonalities and variations that C++ can express.
Just a subset.
It's one subset, but there's many other combinations. And wow, they expressed other paradigms that we knew about.
For example, generic or something.
Generic programming, modules, procedural programming, functional programming, all of these variants depending how I combine commonality and variation. Now, in addition to commonality and variation, I needed two more things. One was instantiation, and the other is binding time. runtime binding, compile time binding, source time binding. But with commonality, variation, instantiation, and binding time, I could describe most popular paradigms of that time.
その当時は、インスタンシエーションと、いつ、バインディングが決まるかというと、コモナリティとバリアビリティが、はい。
多分言ってるのは、その OO はそのシグニチャーが共通であるとか、データが共通であるとか、まあ、データのアルゴリズムに関してバリエーションがあるとか、そういう視点でもってコモナリティとバリアビリティを表現していると。で、シンプラプラはそれもできる、それもできる。それもできるけれども、それ以外にもうコモナリティとバリアビリティを表現する手段を持っている。例えばジェネリックがそうだし、モジュールっていうのはそうだと。だから、OO っていうのはオブジェクトオリエンテーションって1988年にこういうふうに定義されたけれども、それをコモナリティ、バリアビリティという視点から見てみると、こういうことになると。この下、真ん中の下のところですね。C++はそれを超えたものを持ってますよと。こういうことです。で、それをこう、まあ、改めて言われると、コモナリティとバリアビリティ、それからこちらにあるインスタンシエーションっていうのと、それからポリフォルミズムっていうのは、バインディングタイム、結合時点、要するに共通性とそれから可変性をどっかを時点に結合するんだけど、それをコンパイル時にやるのか、それを実行時にやるのかということ。その4つの要素でもっていろいろなその設計を表現できるというようなことを言う。
じゃあ、the binding time in the commonality and variation binding. So, what binding time really means?
So if I have a family of procedures, I will select one from a family. I have a family of procedures. I need to select one. Do I do it when I write the code? Does the code select the right procedure when it runs? That's the difference between a regular function and a virtual function. The family member I choose for a virtual function is bound at runtime. So when I call a virtual function, I don't call a function. It's what Smalltalk calls a method selector. And that method selector is the name of a family of functions.
So it actually selects the method algorithm.
At runtime.
At runtime. Yeah.
Right.
シンプルです。PHP とかの時だと多分マジックメソッドとかのことが仲良くて、リフレクションとかその辺の話のことを言ってると思います。
So you mean the binding time is one element of the design, like
Yes.
commonality and
Yes,
variability.
yes.
You have commonality, variability, and binding time and instantiation.
Hi.
Yeah.
Exactly. Yes. Now, in the meantime, there's a guy named Tim Budd. And he must be about my age or a little older, but he also wrote a book called Multi-Paradigm Programming at about the same time. Have you read this? And actually, there was another guy, a Belgian guy, who wrote a book called Multi-Paradigm Design at about the same time. and in fact, he was at my university. Very bright guy, but just why did he choose that title? That was really strange. Tim Budd was a very honorable guy. He is basically a Smalltalk programmer, and he invented a programming language called Leda. And Leda was designed as a multi-paradigm programming language, like C++. Except not like C++. Because to him, what paradigm means is computational model. So, is this an analog computer, or a digital computer, or a parallel computer? These are different paradigms. So, by the word paradigm, he meant something very different than me.
まあ、同時期に、マルチパラダイムデザインっていう本を書いている人が何人かいるんですけども、一人のティムさんっていう人は、レダっていう言語を作ったんだけど、そこで言われているパラダイムっていうのは、コプレインさんが言っているパラダイムとはまた違った意味でのパラダイムっていうことを意識していて、例えば並列コンピューターだったりとか、シングルだったりとか、その辺のことをパラダイムと言ってて、ちょっとパラダイムの考え方はまた違うもので、言葉は、表現は言葉自体は一緒だったっていうのがありました。
Now, it turns out that he had a great truth, and I intellectually understood it, but I didn't understand that I understood it until 20 years later. So this is like Darwin. If you go back and look at Darwin's notes from his trip on the Beagle, the whole philosophy of evolution is in his notes 20 years before he understood it and published it. He did not know what he knew.
当時はちょっとよく分かんなかったんですけど、20年後彼の正しさが分かってきた。
So, Tim Budd, one of his paradigms was object-oriented. But again, it's a computational model. Now, I'm an engineer. When I think computational model, I think hardware.
コンピュテーショナルモデルって言われたときに、自分は、ハードウェアのことを一瞬最初考えてしまう。
So, I have designed data flow machines. Has anyone ever programmed in pure Lisp? So, no probe. Pure Lisp. Lisp. Or pure, pure Lisp. No assignment. Everything is a function or a constant. That's a data flow machine. Or an analog computer. I used to program analog computers. And what is this object-oriented thing that Tim Budd is talking about? And I was also talking to Larry Constantine at about the same time, and Larry said, object orientation is not a paradigm shift. It's
コンスタントにはオブジェクティブ思考は、パラダイムシフトではないと言ってますね。
It's still a von Neumann machine.
ほんの今のマシンで、この上で。
Now, von Neumann machines are one of the stupidest, most arcane inventions of all mankind. I mean, think about it. I have a whole bunch of bits of ones and zeros, and I drop a ball on it, and it bounces, and when it hits one, depending on the contents of the ball and the memory, it bounces somewhere else. Like, what? What a stupid way to talk about logic. A von Neumann machine is just, it's like a Rube Goldberg device, right? Rube Goldberg. Oh, never mind. It's too hard to describe. Do you know what I mean? No, there were these, he was, I think, an artist. And he would draw pictures of these immense, elaborate machines where you drop a ball here and it goes into a shoe, and the shoe causes a weight to pull a pulley, which releases some feathers that blow into a fan that...
Tom and Jerry. Cartoons.
There was, yes, there was some of this in Tom and Jerry.
絵の具はこうあれ紙にこう吹きつけたりとかなんか流したりとかそんなんで絵を描く人。
So, what Larry Constantine said is object-oriented programming is just von Neumann programming. And he was right. In terms of the mentality of 1988 to 1995 in the popular Oops Law community.
彼の言うフォン・ノイマンマシンのものであると、オブジェクト思考っていうのは、まあ、95年までのオブジェクト思考としては、まあ、その通りだというのは言っている。
Now, I went through 3 levels of enlightenment after this.
この後3つのエンライトメントが、
So, the first level of enlightenment, this isn't exactly how it happened, but it's a good way of presenting the theory,
まず1つ目のレベルですね。
is that, one, there is no OO in C++.
まず1つの話だし、なんかそう
Because object orientation is not just a von Neumann computational model. And all of this, from 1984 until about 2010, was using the term object-oriented when we meant abstract data types.
88年から2010年ぐらいまでは大体オブジェクト思考っていうところをね。
And in fact, in Bell Labs, there was a programmer who was simulating abstract data types in C, and you use function pointers, and you can simulate abstract data types in C.
アブストラクションデータタイプをまあ C で、まあ、その実際ベルケンではやったりした。
And then Brian Kernahan said, C++ isn't really abstract data types. He called them concrete data types. There's nothing abstract about them. They run. So, kind of part 2, really part 1A, is that there are no objects in source code.
2つ目のレベル。ソースコードでオブジェクトがない。
The code that I edit. A C++ program is source code. The code that I edit. There's no objects in there. And I ask people, do you do object-oriented programming? And of course, everybody raises their hands. And I say, when is the last that you wrote an object?
実際書いてるソースにはオブジェクトがない。
And they say, oh, this morning. And I say, what is your programming language? They say, Java. You can't write objects in Java. You're a class-oriented programmer. You wrote a class this morning. And this was the realization that I got from Zvi Lenskov, the inventor of Model View Controller.
MVC をの開発者。
But talking more with Trygve. So what is an object? Or what is the object paradigm? And now we start to go down the DCI route. I mean, objects don't have anything to do with these things over here.
ここでちょっと DCI の話が入ってくるんですけども、そこで言われているオブジェクトはもうこの話は忘れてください。
Kind of.
ほとんど。
These are implementations of abstract data types. So the third realization has several parts. A, object-oriented is about mental models.
3つ目のレベルは、O はメンタルモデルに関する。
It's about operational models, how networks of objects at runtime solve problems.
ランタイムで問題をどうやって解決するかっていう、そういうところを注目している。
So this is the Alan Kay definition.
まあ、ここはアラン・ケイの。
Now, there's kind of two parts to this. And this gets into some of the things I was talking about last time. Are you an employee?
Me?
Yeah.
I'm an employee of myself.
No, you're an employee of self. Self-encapsulation. Are you a programmer?
Yeah.
Are you an attendee?
Yeah.
So, what class are you? Are you male?
Yeah.
What class are you? And we would ask this question, what class are you? And it's the wrong question. What class are you? Homo sapiens. That's his class. So we group everyone here by Homo sapiens male. Where are all the women, by the way?
どうして女性がいないの？ホモサピエンス男ばっかり。I don't think.
We should have at least had Gertrude here. That would have been at least one woman here. So we were confusing class and role. Class has to do with abstract data types. Object orientation has to do with roles. Now, the two are related. B, an ADT instance, so ADT plus instantiation can play a role.
アブストラクトデータタイプとインスタンセーションは、ロールですね。役割、ロールを、演じることができる。
So, yeah.
But you say that ADT itself is not object orientation. But
The what?
ADT is
Right, it's not.
not object orientation.
Right.
But ADT playing role is object orientation. Role,
Right, it's subtle. It's subtle.
is it?
Yeah, and you're about right, I think. But it depends on the details. So, pay attention. I don't know if I will get this quite right. But we start with things we observe in the world, and we group them by commonality and variation. Homo sapiens. We can express those in C++ as abstract data types. And instances of those abstract data types can play a role, and as a role, they are an object. So, But you see the time that I can start here, express something, a family with commonality and variation in C++, multi-paradigm design, just like the book. If I have an instance of that plays a role in a network of objects that are in some mental model, then that indeed is object orientation. So what multi-paradigm design is about is putting together the low-level hardware, if you will, C++, abstract data types, down here. So this is multi-paradigm design, commonality and variation, software families based on domain analysis. So if I'm in telecom, I can find many families. Aerospace, others. Banking, others. And I build my domain model down here. A great way of expressing my domain model is abstract base classes. And then I look at the use cases. Why? Those capture the human mental models for solving problems. They're an algorithm. But they're a special kind of algorithm, and that they're an algorithm of interactions between objects. And these objects start as abstract data types, and then we hook them up to the matrix, allow them to play a role. A role is always defined in a context, and they become something that supports object-oriented programming. So we have two parts of DCI. We have the class part, which is all this stuff we talked about over here, and we have the role part, or the context part. And we marry these together. So, oh, those are.
When it's good time, it's about 1 hour, so when it's good time, we have to break.
The interpreter needs a break.
Okay. Let's take a break.
When it's good time, yeah. When it's good time. Now it's about to go into the DCI part, so.
And I will not go any further, but I just wanted to tie this to DCI to see how people fits in. So I've kind of finished my story.
That's gonna be,
So now we can take questions after the break.
Oh, ready to break there? You mean, no, it's break?
You said you wanted a break.
Oh, it's not. When it's good time, actually.
That's a good time.
Okay.
5
じゃあこの後でこの DC